Third unit is your material characteristics. So generally, we are going to study the characteristic of all the materials which we require for constructing a pavement. So why we need to study the characteristics means different methods need different parameters. It is important to determine the engineering properties of all the materials that we use in the construction. Generally, what kind of materials we require? Four categories. We have soil. And the soil, you have different types of soils like clay soil, peat, silt, sand, and gravel. And your aggregates like fine aggregate, coarse aggregate. Mining materials like cement, lime, bitumen, tar, cutback, emulsion, everything. Other materials like water, fly ash, cinder, polymers, plasticizers. So these are the materials you require. Coming to the soil, in your GT subject, you already know particle size analysis of soils, like how the soils are categorized. So you have dry analysis, dry sieve analysis, and wet sieve analysis. Two types of analysis you have. So for dry analysis, the limitation of test is up to 75 micron size of soil particles. And for wet analysis, it is the limitation of the test is up to 2 micron size of soil particles. So this method is also suitable for separating washout of finer particles of soil dust present on the surface of coarse aggregate. That is a wet mechanical process. So the charts were developed by various agencies based on percentage of soil grains passing through different sizes of sieves. You can see here, this is a soil texture based on particles as according to IS. IS is the Indian Standard Classification of Soils. So according to the IS standards, 1498 and 1970, according to that code, soil texture is classified like this. Gravel, the diameter of the particles range from 75 to 4.75 mm. Here, all the sizes are in mm. Units is mm. IS seed sizes retained on 4.75. What do you mean by retained on? Retained on means it will not pass through the 4.75 mm, and up to 75 mm, everything will come under the gravel. Coming to the sand, which passes through 4.75 and retained on 0.075. That means the size of the particles, the diameter of particles will range between 4.75 mm and 0.075 mm. It's coming to the fines. Fines are nothing but the cells and clays. Sizes are like this: 0.075 to 0.002, and for clay it's less than 0.002. So for the fines, generally we carry out a hydrometer analysis for detailed investigation. 1 micron is equal to 1 into 10 power minus 3 mm, or 1 mm is equal to 10 cube micron. That people know. And sands and silts are further classified as coarse, medium, and fines based on the particle size. Clays are further divided as colloids if their particle size is less than 0.001 mm. Now here is the terminology used by American Standard ASTM designation. Okay. These are boulders. So we call them as gravels, silts, sand, and clay. But here they call us boulders or rock fragments which are greater than 75 mm, and from 75 mm to 2 mm they also call it as gravel only. For 2 mm to 425 microns they call it as coarse sand, and from 425 microns to 75 microns they call it as fine sand, and from 75 microns to up to any extent we call it as silts and clays. Next, coming to soil gradation. This also you already studied in your geotechnical engineering subject. You will be having the uniformity coefficient of soils, coefficient of curvature, the formulas. So there will be different grades of soils like well or dense graded, gap or skip graded, open graded, poorly or uniformly graded. These four different types of soils you have. So this curve is the open graded soil, okay? And this one is the gap graded soil, and this one is the well graded soil. What is the meaning of well graded soil? Means it will have almost all the particles, all sizes of particles. We call it as well graded. Gap graded means it will be missing some soils which are of some particular sizes. So here in the curve you can observe in the starting you will be having different sizes of cells, and later from this point onwards, from the arrow point onwards to here, there is a straight line here, almost straight line. That means no particles are present from this size to this size. So there is a gap in between the curve, and again you have all sizes of particles after that point. So this here, because of this portion, we call that as gap graded soil. Next one is moisture content. So it is also similar to that you have learned in your GT. So for rapid determination of moisture content, we'll be having so many methods like sand bath method, alcohol method, infrared lamp drying method, calcium carbide method, and nuclear radiation method. Finally, moisture content means it is nothing but rate of moisture present in the soil by dry weight. You determine it in terms of percentage, so into 100 units. To test the consistency of soils, this is important for you. Liquid limit test you have done in your GT lab. Liquid limit test. Next one is a cone penetration method. Next one is a plastic limit test. Please go through all these tests once again and to determine the plasticity index. So these are the detailed investigations about the soil. Let us see the problem related to it. Determine the activity and liquidity index of a soil from the following data. Liquid limit he has given us 42%, plastic limit 17.2%, and moisture content as 25.8%. Clay content as 26.4% of particles. Pass it through a 2 micron size sieve. So now plasticity index will be liquid limit minus plastic limit. So it is calculated as 24.8%. Activity means it is the value indicates the type and composition of different minerals present in clay soils. Formula is plasticity index by percentage of clay particles. Value. The value is in between 0.75 to 1.25. The clay may contain light and more light as its major mineral composition. Now, liquidity index you need to calculate. You will be getting around 0.8%. Since it is between 0 to 1, the soil is in plastic state. That is about your problem. Next, this one is very simple problem. Sample was tested in a picrometer to determine its specific gravity. Calculate the specific gravity of the soil using the following data. You already know what is the formula for specific gravity. It is W2 minus W1 by W4 minus W3 plus W2 minus W1. Calculate it, you will be getting around 2.71. W1 is here, weight of empty picrometer. 2 is the weight of picrometer along with the soil. The figure you can see. 3 is weight of picrometer with soil as well as with water. And weight of picrometer completely filled with only water. Here is your W4. Next, determination of soil compaction. So due to compaction, what are the useful changes in soil properties? Density will be increased after compaction, shear strength characteristics will increase, permeability will be decreased, and swell and shrinkage characteristics will decrease, and compressibility will be increased. That is the changes we can expect after soil compaction.